arithmetic value which represent the quantity and used for making calculations, isn't it? Integers is denoted by the letter Z, capital letter Z. So all the fractions or all the numbers which are in the form of P by Q, it is nothing but the rational number. Ma'am, what is this pi? Pi is nothing but it is a special number. Hello dear students. Hi. My name is Vibha, Mathematics Faculty, Vidhyaashram, Temple of Excellence, Mysore. In this session, we are going to study what do you mean by the number system or the number theory. So what are all the topics I am going to cover under this session is meaning of a number you are going to have, and then types of numbers, and then properties of numbers. Okay, now let us move on to meaning of a number. A number is nothing but it is an arithmetic value which represent the quantity and used for making calculations, isn't it? A written symbol like 3, here I have taken it as 3, you can take it as 4, 5, 1. These are all going to be as represent a number. That means a numerals you are going to call it as, okay? Symbolically. So here the number system is a writing system for denoting the number using the digits or the symbols in a logical manner. This is important. In a logical manner, you are going to represent or denote the number system. And here we are going to use the numbers as from 0 to 9. You know already 0 to 9 we are going to use the numbers, and then that is nothing but 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 8 and then 9. We are going to use those keys. Okay. So here each these we are going to denote it as numerals. Are you getting? 8 and then 9. Whatever you are going to make a number more than 9, it will be taken from these numerals only. 11, 12, 13, 14, or repeated numbers of this itself. Are you getting? So this is a meaning of a number. Next we'll be moving on to the number 0. This is very, very important because without 10 you cannot move it to 11, or without 100 you cannot say it as 101. So 0 is very, very important role in a mathematics, and it is as a placeholder in the place value of the number system. Okay, and acts an additive identity for the real numbers in the algebraic structures. And algebraic structure, that means, what do you mean by additive identity? Whatever you are going to add a number to the 0, the same number you have to get it as. That is called additive identity. That means if I am going to take it as 2, what is 2 plus 0? You are going to have it as 2 plus 0 is nothing but 2 itself. If I am going to take it as negative number also, if I am going to add for that negative number 0, you are going to get same negative number. For example, I can take it as minus 5 plus 0, which is nothing but minus 5 only. So whatever you are going to get, what is that additive identity, whatever you are going to add the 0 to the negative number or to the positive number, you are going to reflect as the same number. That is acts as the additive identity for all the real numbers. Okay, now we'll be moving on to the real numbers, and also here 0 is nothing but we are going to have it as to show that is nothing. Here I have taken, there were 3 apples, but now there are none. Now there are none means there are no apples present in the basket or whatever you are going to take it as. Understood? So next we'll be moving on to what do you mean by the types of numbers. Under the types of numbers, you are going to study what do you mean by this real number also. Okay, so here the types of numbers are natural number. Natural number will be counting from, always it will be starting from 1. Natural number will be always starting from 1, 2, 3, 4, 5, and etc. It will move up to infinite numbers. So that only I have taken here dot dot. That means infinite numbers it will be moving. That is going to be known as the natural number, and natural numbers is denoted by the letter n. The natural number is denoted by the capital letter n. Next we'll be moving on to the integers. Integers are nothing but it is a set of all whole numbers which will be having the negative numbers as well as the positive numbers, including 0. Whole number means what? You know already, whole number is nothing but when the natural number, whole number is nothing but when the natural number included with the 0. When the natural number included with 0, that is, we are going to denote it by W. 0, 1, 2, 3. These are going to be known as the whole numbers. Okay. When natural number includes 0, it becomes the whole number. Integers means when the integers having the whole set of all whole numbers along with the negative numbers as well as the positive numbers, it is going to be known as the integers. And integers is denoted by the letter Z, capital letter Z. Okay, so next we are going to have it as here. How we are going to denote, how we are going to write it? See, 0 to the left hand side you are going to write always the negative integers, and 0 to the right hand side you are going to write it as a positive integers. Okay, left hand side of 0 will be containing the negative numbers, right hand side of 0 will be containing the positive numbers. Overall we are going to have it as set of integers. Understood? So here I have taken also set of all whole numbers but includes a negative set of natural numbers. You know already set of natural numbers is only the positive. Negative set of natural numbers means you are going to have it as -1, -2, -3 like that. Set of all a positive natural number, set of all negative natural number along with the whole numbers. That means whole number will be starting from the 0. So the total you are going to have it as integers. Next we'll be moving on to the real number. Real number, as already I told you, we have talked about the real number in additive identity for the 0. Real number means all the positive number, all the negative number along with the 0, that means the integers, set of all integers along with the fractions, decimals you are going to have it as, that means 1.3, 1.4 like that. See, set of all positive and negative integers, fractional and decimal numbers without imaginary number. I'm going to tell you what do you mean by imaginary number. The real number will be not included the imaginary number. So what do you mean by then? Here the fractional and the decimal. Fractional means you are going to have it as like decimal 1.2, 1.3, 1.5 like that you are going to have it as. That is called the fractional. √2, √3, √4 like that. So that numbers are also included in the real numbers. Are you getting? So here you are going to have without imaginary numbers. Imaginary means it will be in the form of, imaginary means I. Imaginary means just the symbol I. This is a root. Okay, I means the value of I is always negative of -1. The value of I is always negative of -1. That means negative root. You all have studied in your lower classes the positive root. That means square root of 24, square root of 25, square root of 16. Like that you have studied, but you have never come across what do you mean by the square root of negative number. You will be studying the square root of a negative number under the imaginary numbers. Are you getting? That means under the complex numbers. Under the complex numbers, you are going to get the imaginary number. Okay, so this is what the real number, and also real number is represented by the symbol R, capital letter R. This you have to remember. The set of natural number is n, set of integers is z, and set of real numbers is nothing but the R. Okay, next we'll be moving on to the rational number. Rational number means any number that can be written in the ratio, that is one number over the another number. That means you can write it as 4/3. One number over the another number, 5/6, 1/2. These are all going to be known as the rational numbers. And here I have taken rational numbers means for this one number I have denoted generally as P, and for this number I am going to denote it as Q, which is in the form of P/Q. Which is in the form of P/Q, and the rational number is denoted by the capital letter Q. Understood? So all the fractions or all the numbers which are in the form of P/Q, it is nothing but the rational number. Next we'll be moving on to the irrational number. Irrational number means that cannot be expressed as a rational number. It is an irrational number which cannot be expressed as a rational number. It is an irrational number. The same thing here. Okay. And irrational number, it is denoted by the letter P. Sometimes we are going to denote the irrational number by letter I also. Sometimes according to the situations of the problems, we are going to take this symbol, okay? Or sometimes we are going to write it as Q dash. Q dash is nothing but which is not a rational. Q means which is a rational, Q dash means which is not a rational, that means it is an irrational. Understood? Next we'll be moving on to the complex numbers. As I already told you, real number, here we have defined real number without imaginary. Imaginary means root of -1, which is nothing but the I, correct now? Wherever the I present, that is the imaginary. So that's what I am telling you, the imaginary root will be coming under the complex number. Then what do you mean by complex number, ma'am? Complex number is nothing but which will be written in the form of A plus IB. That is going to be known as the complex number, which is in the form of A plus BI, or you can write it as A plus IB. I already told you I means root of -1. Understood? So this is denoted by the capital letter C. Complex numbers are denoted by capital letter C. Understood? Next we'll be moving on to the even numbers. What do you mean by the even numbers? Even numbers means which can be divided by only 2. That is going to be known as the even numbers. The numbers which are exactly divisible by 2 are called even numbers. And this can be also a positive number, even number, or the negative even number. So you can take an example of 42. 42 is divisible by 2? Yes. That is, you can divide this by 2 means divided by 2. I can have the answer as 2 2s are 2 1s are. Correct na? You are going to have it as 21. But whatever the number you are taking, it must be divisible by 2. Then only it is called as an even number. Otherwise, you can take also negative numbers. For example, I am going to take it as -12. -12 is divided by 2. Yes, it is divided by 2. If you divide 12 by 2, it will be giving you the value -6. Since I have taken here negative value, it will be coming as negative number only. Okay, so either the positive number which will be divisible by 2 or the negative number which will be divisible by 2 is nothing but the even numbers. Next we'll be moving on to the odd numbers. What do you mean by odd numbers? Which are not exactly divisible by 2 are going to be known as the odd numbers. Odd numbers can also be negative also. Odd numbers can also be positive also. See, you cannot see 43. The same example I am going to increase with the number 1. So 43 is divisible by 2. No, it is not divisible by 2. You are going to get the fractions, correct? Na decimal value. 2 2s are, next you are going to take it as 2 1s are 2, correct na? 0.5 you are going to get it as. So this cannot be divisible by 2 you are going to have it as. Therefore, this cannot be a, what is that? A even number. This is always a odd number. Okay, next we'll be moving on to here. I have taken some example of a negative. -3 which cannot be divided by 2, -15 which cannot be divided by 2, 7, 9 and 17, 25 and so on. You can take it also of 43 what I have taken here. Next we'll be moving on to the prime numbers. What do you mean by the prime numbers? The numbers that have 2 factors only. This is very important. And the number which is having the 2 factors means 1 and itself. 1 and itself which can be having, see, the 2 factors only which is 1 and the number itself. In other words, you can have the number which is divided by 1 and the number itself. That is going to be known as the prime number. For example, you can take it as 2. 2 is divisible by 1 only and multiplied by 1 itself. Correct na? You do not have any other factors. 4. What is 4? 4 is divided by 2 also, divided by 4 also. It is having 2. Divided by 1 also. It is having 3 factors. Correct na? So therefore here the number which is having, the number which will be having or which will be multiplied by 1 and multiplied by number itself, the same number itself is going to be known as the prime numbers. Here I have taken so many numbers or the numerals. 3 which will be multiplied by 1 and itself, which do not have any other factors. 5 also, it will be multiplied by 1 and multiplied by the number itself, 5 itself. And 7 also, 11 also, like that. So many numbers, prime numbers you can have. And here you can observe, dear student, 2 is going to be known as what? 2 is the even number, correct na? And it will come under the prime. So it is only the number which is the even prime number. 2 is only the number which is going to be known as even prime numbers. Understood? Even prime numbers. Okay. Next we'll be moving on to the composite number. What do you mean by the composite number? Means is a number such that it has more than 2 factors. As I told you, 4, it will be having 1 as a factor. It can be multiplied by 1. It can be multiplied by, what is a 2 into 2 is 4. 4 into 1 is 4. Correct na? So like that. So for example here, same. 4 is a composite number that as the number 4 is divisible by 1, 2 and as well as 4. Correct na? You can take it also 6 which is divisible by 1 also, 2 also, 3 also. 1 by 6 is 1, 6 by 2 is 3 and 6 by 3 is 2, isn't it? So therefore that also you can take here 6, 8, 9, 10. The number which is having more than 2 factors are going to be known as the composite number. Okay, next will be here. The number 1 is neither a prime nor a composite. Why? Why? Because you are going to use it in a prime also, you are going to use it in a composite also. Therefore, it can be said as it will be neither a prime number nor a composite number. 1 can divide all the numbers, 1 can be multiplied with all the numbers. Okay. Next we'll be moving on to the cardinal number. Ma'am, what is this special word cardinal? Why we are going to use this one? Cardinal number means you are going to take some list. List means I am going to take you as like a basic mathematics students of a class 11th. A basic mathematics students of a class 11 means particularly some numbers you are going to get. That is what the something I have represented here. Okay. The cardinal number defines how many of something are there in the list. Such numbers are nothing but the cardinal number. That means in the class 11th of the basic mathematics students, there are 40 students, there are 50 students, 12 students, like that. So that's what I have, such as 1, 5, 10, etc. As I told you, 40, 50, 20, like that. There are 50 number of students in a basic maths class 11th, and there are 30 students in a maths of class 12th, like that. You can take it as whatever the list you are having, that is what the something I am going to represent. It can be a student slates, it can be a food items, anything you are going to take it as. Next, we'll be moving on to the ordinal number. Don't confuse in between the cardinal. Cardinal is nothing but the list what we are making. Okay, how many numbers are there, or how many items are present in the list, or how many names are there in the list. That is the cardinal number, total. Ordinal number means you are going to particularly select the name of that list. You're going to select particular name, means it can be a student name. If I am going to take it as class 11 basic students list. If I am going to take it as food item, particularly that food you are going to select it as. That is called as the ordinal number. It is, I am going to have a sentence as ordinal number explain the position of something. Okay, as I told you, I can take the second student or the third student, fourth student. I can, if I go to hotel, I can order, the menu will be there. The menu is nothing but the cardinal numbers, the list, correct now? So in that I am going to order any one or any two, either the juice item or food item, that any one or two I am going to, second place, third place, it can be filled. So any one item I am going to order there. That is going to be known as the ordinal number. Next we'll be moving on to the pi. Ma'am, what is this pi? Pi is nothing but it is a special number which is approximately equal to these value 3.14159. Ma'am, where we are going to use this one? We are going to use this in the geometry. That means if you take it as a circle, area of a circle is nothing but pi r square. There we are going to use it, this pi, as a special number, and it is defined as the ratio of the circumference of the circle divided by the diameter. Ratio of the circumference of the circle divided by the diameter. This is called the diameter of the circle. Are you getting? Radius is nothing but from a point to any point on the circle, from the center to any point on the circle. Understood? This is a pi. Next we'll be moving on to Euler's numbers. Now what do you mean by the Euler's number? Euler's number is nothing but it is an exponential number. E we are going to name it as. That E also, for to get some value in the, what is that, class 11th, we are going to use this Euler's number. Okay, that is nothing but you are having 2.71882818 is the value of the Euler's, which is come under the irrational numbers. Irrational numbers means what? Which are not the rational. It will be coming under the irrational number. Are you getting this? This is what the Euler's. Next we'll be moving on to the properties. As I told you, properties of the numbers, basically stated for the real numbers. Real number means commonly you are going to take, wherever you are going to denote the properties of the numbers, commonly we are going to take it as, or we are going to consider it as a set of all real numbers. It will be holds good for real numbers. Okay, so here first property is nothing but the commutative property. What do you mean by the commutative property? If A and B are two real numbers, real number, it can be anything. What is that? You can choose a positive number, you can choose particularly negative number, or you can choose fractions, or you can choose the decimals. That are going to be known as a real numbers. Real number A and B. In general, I have taken, instead of taking particular number, you can choose that number as A and B. So A and B are two real numbers. Then according to the commutative property, this is a rule of the commutative property, that is A plus B must be is equals to B plus A. For example, if I am going to take it as A is equals to 1 and B is equals to 2, 1 plus 2 always will be equal to 2 plus 1. That is 1 plus 2 is 3 and 2 plus 1 is also 3. This is going to be known as the commutative property under addition. Addition means we are adding. Okay. Next we'll be moving on to commutative property under multiplication. Multiplication means you are going to have it as, see, for example, I am going to take it as let A is equals to 3 and B is equals to 4. So if I am going to multiply the two numbers, 3 into 4. What is 3 into 4? Which is nothing but 12. Correct now? Which will be is equal to 4 into 3. What is 4 into 3? It is also 12. Correct now? So that is going to be known as the commutative property under multiplication. Next we'll be moving on to the associative property. If A, B, C are the real numbers means anything you can choose. So the commutative property is defined under addition, that is A plus B plus C must be equal to A plus B plus C. Here the bracket will change. Here I am going to write what is A is equals to, I am going to take it as let A is equals to 1, B is equals to 2, C is equals to 3. Now I am going to have it as A plus B plus C. Correct now? What is that? 1 plus 2 plus 3, which is nothing but what? You are going to have it as 1 plus 2 is 3 and 3 plus 3 is 6. I am going to add here 3 plus 3, which is nothing but 6. Similarly, I am going to do it here. What is that? A plus B plus C. That is 1 plus 2 plus 3. What is this will be equal to? 1 plus 2 plus 3 is 5. First you are going to always solve within the bracket, then you are going to come outside the bracket. So 2 plus 3 is 5, which is nothing but 6. You can observe, dear student, these two are equal. Therefore, this holds good for associative property. Next, we'll be moving on to the associative property under multiplication. The same example, you can take it as what? I'm going to give an example of same values, which is nothing but 1, 2, 3. Here, I'm going to take it as the multiplication. Correct na? Here, let me take it as multiplication. Same value I am going to consider. The multiplication you are going to have it as, what is that? Let A is equals to 1, B is equal to 2 and C is equals to 3. In this, I am going to take it as 1 into 2 into 3. So here, if I am going to multiply first, what I need to do? I have to take first the bracket. Correct na? 1 into 2 into 3, that is nothing but 1 into 2 is 2 into 3, which is nothing but 6. 2 into 3 is nothing but 6. Similarly, here I am going to choose 1 into 2 into 3. First, I need to solve the brackets. 2 into 3 is 6. Therefore, 1 into 6, which is nothing but 6. Therefore, this holds good for associative property under the multiplication. Okay, this extension you are going to study in your 11th standard. Okay, next we'll be moving on to the distributive property. Distributive property is nothing but A, B, C are the three real numbers. Then according to that property, A into B plus C is equal to A into B plus A into C. So here I am going to take it as let A is equals to 1, B is equals to 2. So therefore, and C is equals to 3. If I am going to take it as A into B plus C, what is that? 1 into B, that is 2 plus 3. Which is nothing but what? First, I need to solve the bracket. Bracket is 2 plus 3. 2 plus 3 is 5. 5 into 1 is 1. 1 into 5, which is nothing but 5. Let me now do for the right hand side. A into B plus A into C. What is that? A into B? A into B, which is nothing but 1 into 2. A into C, if I am going to do it as, that is 1 into 3. You have to add these two. That is, you are going to have it as, what is that? A into B plus A into C, which is nothing but 1 into 2 is 2 plus 1 into 3 is 3, which you are going to get it as 5. See, these two are equal. Therefore, this gives you the distributive property. Any number you can write it as 3 numbers, you can write it as like this, okay? It must give the same result. Similarly, for the distributive property, A into B will be is equals to the B into A also. Next we'll be moving on to the, this will come under the associative, okay? Next we'll be moving on to the closure property. If a number is added to another number, then the result will be the same number only. That is going to be known as the, or result will be a number only, not same number. It will be another number, but it's a number itself. That is going to be known as the closure property. Closure property means you can have it as, what is that? 2 plus 5. What is? This is number, this is a number. What it will give you? It will give you a letter? No, it will give you another number only, which is nothing but 7. Correct na? A plus B is equal to C. That's it. A plus B is equal to C. Number plus number gives you another number. That is going to be known as the closure property, where A, B, C are any real number. You can take it as. Next, we'll be moving on to the additive inverse. Additive inverse means the number which will be taken and the same negative number is added, which will give you the result 0. A number you are going to select. For that number, the same negative number is added, you will be getting the result as 0. It is going to be known as additive identity or additive inverse. See, you are going to additive identity, not additive inverse. See, if a number is added to its own negative number, then it is, the result will be what? 0. A plus minus A. I can take it as what? 2. Negative number of 2 is minus 2. Plus minus 2. So what I am going to have? Plus into minus is nothing but minus, which is nothing but 2 minus 2 will be is equal to 0. This is going to be known as the additive inverse. Okay. Next we'll be moving on to the multiplicative inverse. Whatever you are going to take the number, that reciprocal number will be multiplied and then will be giving you the result 1. A number you are going to take, for that number you are going to multiply a reciprocal of the number which will be giving you the result 1. It is called multiplicative inverse. Here you are going to have the definition. If a number apart from 0, why apart from 0? If you multiply anything for 0, you are going to get it at 0 only. You are not going to get it as 1. I want 1 as a result. So here a number apart from 0 is multiplied to its own reciprocal. Here A into 1 by A. Here I have taken 23 into 1 by 23. Otherwise I can take 5 into 1 by 5, which will be giving you 5 will get cancelled 1. Otherwise minus 6 into minus 1 by 6. 6 will get cancelled. Minus into minus is plus, which will be giving you 1. Whatever you take the negative numbers or the positive numbers, that reciprocal multiplication will be giving you the answer as 1. It is a multiplicative inverse. Next we'll be moving on to what? The zero productive property. What do you mean by the zero productive property? Zero productive property means if A into B is equal to 0, where A and B are any real numbers, either A will be equal to 0 or B will be equal to 0. Either A will be equal to 0 or B will be equal to 0. That is, then only it will give you the product as 0. For example, you can take it as A is equal to 2 and B is equal to 0, or B is equals to 2 or B is equals to 2, A is equals to 0. 2 into 0 is 0, 0 into 2 is also 0, isn't it? So that property will be the zero productive property. Next we'll be having a reflexive property. What do you mean by reflexive property? The mirror image. When you stand in front of mirror, what you are going to see? Your image, isn't it? That is going to be known as the reflexive property. So here the definition, this property reflects the number itself. That is, A is equals to A, 9 is equal to 9, 2 is equal to 2, 3 is equals to 3. That is going to be known as the reflexive properties. All this we are going to use, the extension of this we are going to study in your 11th standard basic mathematics. So here you have to remember what do you mean by the types of numbers and then the properties of what you are going to denote it. Understood? Hope this session is, you understood this session with the numbers and also the properties and also the meaning of the number. So next session will be moving on to the shapes, which is nothing but the 2-dimensional and the 3-dimensional shapes. Thank you, dear students.